Hello friends, welcome back to our YouTube channel Mechanical Engineering Exams Made Simple. Friends, we know that Assistant Motor Vehicle Inspector examination is going to be conducted on 23rd April. Hardly we have 1 month and 20 days. So start your preparations very well, and by April 1st you must be starting your revision. Okay friends, in this video let us see some of the few important and good questions from your engineering materials and last topic, okay, production technology, right? So from that we see some good bits from what you call this iron carbon diagram and other things, okay, and especially heat treatment. Let us see friends, cooling curves, etc. So cooling curve is obtained by plotting. So which of these combinations is it? Time versus temperature, or temperature versus time versus composition, or composition versus time? So actually cooling curves are drawn for time versus temperature, composition and temperature. That's called phase diagram, okay friends. But that is called equilibrium diagram, okay. If it is iron and carbon, that's called iron carbon equilibrium diagram. But this is cooling curve is drawn between time versus temperature. That is the answer. Next, during alloy solidification the temperature is, what is the correct answer for this? Is it going to be constant, or increases or decreases, all of the above? So friends, actually during alloy solidification the temperature is constant. Why? Any phase transformation change takes place at constant temperature, whether it's from solid to liquid or liquid to solid, okay friends. So that we know from thermal engineering, right? So from solid to liquid, that's called melting point temperature, and liquid to vapor or gas, vapor especially, that's called vaporization temperature friends. But during alloyed solidification, because after all it is also a solidification process after it is being converted into molten shape or molten metal. So on solidification it is going to give various phases, different phases depending upon the reaction, whether it is eutectic reaction or peritectic reaction, something like that, eutectoid reaction, etc. So now, but here during alloy solidification the temperature as usual it is going to be constant, no increase or no decrease, right? Before solidification the some amount of undercooling occurs. So this is about the solidification. So after a pure metal, that means we are heating the metal to very high temperatures above its melting temperature, and we are going to melt it and cool it. On cooling, the composition of the alloy is going to change for various composition and various temperatures, okay friends. So now here that's called your iron or iron carbon equilibrium diagram, or any equilibrium diagram. If you are drawing the composition of that particular alloy. So for steel it is an alloy of iron and carbon. If your equilibrium diagram is drawn for iron and alloy, carbon, okay, with percentage of carbon on x-axis and temperature on y-axis, that's called iron carbide or iron carbon equilibrium diagram. But here before solidification some amount of some amount of undercooling occurs. In which case? In alloy case, or in pure metal, or in tertiary alloy, or none of the above. So this is your in pure metal only, before solidification some amount of undercooling occurs, but not in case of alloys or tertiary alloys friends. Next question, eutectic solid solution or eutectic solid solidifies at, whether it is at varying temperature or constant temperature, both constant and varying temperature, or none of the above. So it is going to take place at all these reactions friends, peritectic reaction, eutectoid reaction, okay. So various compositions also, hypoeutectoid, eutectic, hypoeutectic, depending upon the composition of the or the presence of carbon, how much percentage of carbon, and those reactions are going to take place from liquid to solid, solid to solid, two solids, etc. So those temperatures are given accordingly, the temperature names, right? So eutectic solid solidifies at what temperature? It is going to be solidifying at constant temperature. Accordingly, it is called eutectic reaction. Next, Right, friends? Lever arm rule is used for identifying. This is a very, very important question, friends. So, what with the help of a lever arm rule, what we are going to obtain? Is it amount of phase or amount of temperature or amount of heat or solidifying temperature? So, in no way it is concerned with the temperature, friends. It is concerned with the amount. Okay, the correct answer is amount of phase. Various phases are available. Various phases are going to be formed depending upon the composition, temperature, cooling and heating. So, those for example, various phases: ferrite, cementite, perlite, austenite, bayanite. Okay, martensite phase is the toughest, okay, hardest phase of all the phases of the iron carbon diagram. Ferrite and cementite, they are going to give perlite. So, like that, sorbite, various other forms of various other phases are there. So, please be conversant with your iron carbon diagram, from which you can expect one question minimum for each topic. Even if you get one question, that will be a great thing, because actually in the syllabus we are having 8 topics, each topic having minimum 20 topics. So, per topic that subtopics, okay, even if you get one question for one subtopic, it will be covering the entire syllabus. So, on an average I am counting 20 marks from each topic for from 8 topics of the syllabus for your APPSC, sorry, TSPSC AMVI, friends. Okay, next, number of degrees of freedom of a system in equilibrium condition is related to, this is related to what? Number of degrees of freedom. Is it temperature and pressure, only pressure, number of components and phases present, or only temperature? It is going to be connected with your number of components and phases present. You have to remember the words, keywords, number of components and phases also. Right. Now, in a monovariant system, the degrees of freedom, okay, degrees of freedom is equal to C plus P minus 2, C plus P minus 2, friends. F is equal to C plus P minus 2. F is the number of degrees of freedom, C is the number of components, P is the number of phases, and minus 2 is a constant. So, this is the relationship between F, C, P. Let us write down. F is equal to C plus P minus 2. F is the number of phases, C is the number of components, P is the number of phases, and 2 is a constant. So, remember this formula for your exam. Now, in a monovariant system, the degrees of freedom is, so he is clearly saying that it is monovariant. So, what should be degree of freedom? It should be 1. Yes or no? 0, 2 and 4 cannot be the answers. So, the correct answer is 1. Right. Next, an example for two metals completely soluble in liquid state and partially soluble in solid state is, so what is this? Combination of metals which have what you call, they are soluble in liquid state completely, and partially soluble in solid phase. What are these combination of metals? Is it copper silver, copper zinc, lead tin, or gold copper? The answer for this is your C, lead and tin. Right. An example for two metals completely soluble in liquid and solid is, so what is the example for the two metals which are completely soluble in liquid and solid? What is that? Is it copper nickel or lead bismuth, lead tin, or all of the above? The correct answer for this is A. That is where copper nickel. So, please remember this, friends. Of course, you don't have the the what you call equilibrium diagrams for other metals, but iron carbon diagram is a very, very important diagram, equilibrium diagram from your examination point of view. It is there in your syllabus. So, become thorough with that particular iron carbon diagram. You can expect to minimum one question or maybe two questions also, right, based upon the composition and based upon the various phases present, and also temperature and also reactions like eutectic reaction, eutectoid reaction, like that. Okay, friends? Right. Bismuth and cadmium phase diagram is an example for, what is this? It is an example for two metals completely soluble in liquid state and insoluble in solid state. Next, in a eutectic reaction, this is very very important. Eutectic and eutectoid reactions are very very important, friends. So please go through the iron carbide diagram, right? So I think there the temperatures are 700 plus one thing and 1100 plus one thing. Okay, eutectic and eutectoid. If I am not wrong, anyhow, please check the iron carbide diagram for eutectic reaction on what happens at that particular composition and temperature for different compositions, and also what happens at eutectoid temperature also, right? So please become conversant with those two equations, especially eutectoid and eutectoid reactions. So here the question is, in a eutectic reaction, liquid transforms into two solids, or liquid transfers into one solid, or liquid transfers into three solids, none of the above. So three solids is out of question, friends. So either it should be A or B. But what is the correct answer? The correct answer is A. Liquid transfers into two solids. Liquid transfers into two solids. Solid 1 plus solid 2. This is your eutectic reaction. Liquid phase reacts with solid phase to give a different solid phase called. What is this? So he has just changed the question, right? Is it eutectic reaction, or eutectoid, or peritectic, or peritectoid reaction? So here the question is liquid phase reacting with, so L plus S giving S. Let us write down. L plus S1 gives to S2. Liquid reacts with solid 1 and gives to solid 2. What is this reaction is called? It is called peritectic reaction. So friends, remember these reactions: eutectic, peritectic and eutectoid reactions. Now, eutectic composition refers to, is it two metals completely soluble in solid state, two metals partially soluble in solid state, two metals completely insoluble in solid state, or all of the above? So we have seen just now for the question eutectoid reaction, right? So what was the answer? A was the answer. Liquid transfers into two solids. Here also something like that. Two metals completely, let us see what is the answer for this. The answer for this is two metals completely insoluble in solid state. Right. Next, friends, eutectoid transformation. Now question is about the eutectoid. Is it liquid to liquid, or solid to solid, or liquid to solid, or none of the above? So what is this eutectoid transformation? So this is going to be solid to solid transformation. Solid to solid transformation. S1 to S2. S1 means solid 1 and S2 means solid 2. Next, temperature at which eutectic composition solidifies is known as. What is this temperature? Simply he is giving us the hint that it is related with something with eutectic. Okay. But for confusing, he has given solidification temperature, melting temperature, peritectoid temperatures. It is ruled out. So the confusion may arise between solidifies, because he has used the word solidifies. Here you may tend to use solidification temperature or melting temperature, but he has given the hint itself. It is called eutectic temperature. Eutectic temperature. Okay, friends. In this video, we have seen a few important good questions, examination point of view questions from your AMVI Assistant Motor Vehicle Inspector, second paper TSPSC Automobile Engineering, from the syllabus topic number 8 in your syllabus, that is production engineering and engineering materials. In the next video, we will come up with some more important questions for your examination, friends. Let us meet in the next video. I am offering online batches. If you are interested, I have got a study material also for objective questions and also theory part. Okay, that is study material and also objective question bank also for reasonable prices. If you are interested for coaching, online coaching, or your study material or bid bank, you can call me or mail me on the number and mail ID which I am going to provide in the description box. Okay, friends, let us meet in next video.